How many zeros do I have? 6. But all the 6 have 6 zeros. Okay, there are 4 zeros at pi, and there are 2 zeros elsewhere. If there are 6 zeros, there are many choices you can allocate. So I can give 3 and 3, and so on. Okay, so let's look at various choices for this particular example. So here's P naught. Yeah.
Would that be this minus before 1/2?
Oh yeah. So this is minus sign. Okay. You can put a minus in here if you want. Okay. P naught, F naught, and H naught. Okay. So let's see. So where are the zeros for P naught? There are how many zeros at pi? Minus 1? 4. So there are 4 zeros, minus 1. And where are the other zeros? Okay. So if I look at this, the Z transform right here. Okay? We see that the coefficient is real coefficient, right? So I have to have, how many choices do I have? If this is a real coefficient polynomial. How many choices of 0 do I have? I have 2 zeros, right? Can it be arbitrary 0? Can it be here and here? No, why? Why not? It has to be complex conjugated. Right? That's one choice. Okay? So it has to be here and there. That's one choice. Where's the other choice? They're real, okay? That's one choice. The other choice is here on the real assets, right? So which choice do I have here?
Second.
Why? Suppose you don't do B minus product. If you don't find that exact value, how do I know that it is on the real axis?
Because it has green solution.
It
has green solution.
Suppose you don't find a solution. If you find a solution, you can plot it, right? If I don't find a solution, okay, how do I know that the choice is here?
It's outside because we masturbate
No, don't look at that. I don't want you to know to find a solution. Intuition. How do I know that the choice is this but not that? Why? You accept that the 2 0 will be the real value, right? So it's on here. If this is C, some value. C is the solution for that, okay? Where is that? What is that? 1 over C. Why? Okay, good. The product of two roots is 1. That's one way to see it. What's the other way to see it? Let's make use of the fact that this is what? It is, if you look at the phase of that function, what is that phase? Phase is minus omega, right? So this is linear phase. What do I know about 0 linear phase system? Yes, you can learn about that. What is the 0 for linear phase system? It has to be inverse each other, right? For linear phase system, you can show that if Z naught is a 0, Z naught inverse is also a 0. 0 come in pairs. Okay? Because you can flip this, right? If we flip that, then you can show that the inverse also in the solution. Okay, so if it's C inverse has to be a solution. Okay, so we know that there are 4 zero pi and a pair of 0 on the real axis, and the magnitude is basically inverse to each other. Is that okay? So let's discuss how do we distribute or divide this 6 zero into F naught and H naught. And let's distribute them such that you have orthogonal. So the first choice here, give me a orthogonal solution. And then we have linear phase later on. Okay, so second choice here, linear phase. And okay, we'll use other places later on. Okay, so how do I distribute the 0 of P naught to F and H such that I have a orthogonal solution? Okay, so if you choose a 0, let's say C over there to F naught, then C inverse have to be in H naught. Okay, because they related as the inverse. Right? If you plug Z1 in here and set out with a 0, then Z1 inverse will also be the location of H naught. Right? So it means that if I assign this first 0 to F naught, if I want to maintain orthogonality, where is the other 0 have to go to? To H naught, right? Let me go over here. How about 0 at 4 at 5? This one have 2. Why is it? This one have 2. Because if you look at this, right? How suppose F naught has 10 0. How many 0 does H naught have? 10. Exactly the same order. Okay? So and then if you plug in Z equals -1, also -1 here, right? -1 is O inverse. Okay? So it means that, and there are 4 to distribute. They have to be equal. Okay? So they have 2 and 2. And for this example, this is one example, right? And what is the other choice? The other choice is, you can swap this, but that's just redundancy. So if we don't care about redundancy, this is the only orthogonal solution for this particular factorization, right? Because this 4 0 has to be 2 and 2, and this pair has to be distributed. C here and C inverse there. So that's the only solution for orthogonality in this case. Yes. Okay. So orthogonality, one of the ways to check is that whether F naught in the time domain is a flip of H naught. Okay? In Z domain, it means that if there's a 0 at Z1, the inverse 0 has to be in H naught. Okay? So that's basically tell us how to distribute the 0 P naught. Right? If I choose a 0 F naught here, let's say C, and C inverse, we have to go to H naught. Okay, so it means that well, as I said, tomorrow we will discuss why this is the case. Okay? Yeah.